Well, let me try to remember what all mistakes are. Number one mistake. No, I don't think that was all. So a common mistake that a lot of people did is it says releases 500 joules of energy. So this releases tells you that this Q is going to be negative. It might have said gives off, loses, or some other description, and you had to plug in a negative here. Another common mistake is delta T is final minus initial. So if it goes from 20 degrees Celsius to 10 degrees Celsius, this is your initial, this is your final. So your final's here, your initial's here. So it would be 20 minus 10. No, it would be 10 minus 20. So your final first. So negative 10 degrees Celsius. A lot of issues going back to the mole. So for example, on question 13, it asks you for so many moles of lead. Let's say it said 5 moles of lead. Well, remember you have to look up at the periodic table the conversion factor. So lead is right here, and it's 207.2 grams per mole. So 5 mole of lead is equal to, or has a conversion factor of 207.2 grams of lead per 1 mole of lead. Moles of lead cancel out, giving us grams of lead left. And we just plug that into the calculator. Several people did this correctly and just put 207.2 and forgot to multiply. Some people used 18 for water. This is supposed to be 1,036 grams of lead. The main issue is when we start getting to 15, either a lot of people didn't do it or did it completely incorrectly. That's mainly going to be the topic of the test, is 15 and onward. Another thing is y'all are taking way too much time. I gave y'all Thursday and Friday to do it, but the test is currently planned for 1 day. Which means you have to do like these problems in 50 minutes. So let's come up with an example similar to 15. I'm going to make up numbers. So let's say it says 150 grams of water That's at, and let's make this an even 30 degrees Celsius, is mixed with 200 grams of water. That's at 80 degrees Celsius. So we have 150 grams of water that's at 30 degrees Celsius, and it's going to some final temperature, so some TF. We also have 200 grams of water that's at 80 degrees Celsius, and it's going to some final temperature. Every arrow represents an equation. So if we have a change in temperature without a phase change, we use this equation. These arrows aren't in the same direction. We need to make them in the same direction by making one of them negative. This is where the heat gained equals negative heat lost comes from. This water is heating up. This water is losing energy. So this one's gaining it. This one's losing it. And because these arrows are in opposite direction, we have to add a negative before we set them equal to each other. So here we're going from 30 to final temperature, and we have a mass of 150 grams. So our mass is 150, or change in temperature would be final minus initial, and our CP for water is 4.184. We add our negative here, and we do the same thing on this side. On this side, our mass is 200. For change in temperature, we're going from here to here. So our final minus initial. And CP for water is still 4.184. A lot of people set this up correctly, but didn't do the math. So let's review some algebra. If you have something like this, A times something in parentheses times B. So I'm going to span these parentheses out temporarily. So I have A times B plus C times D. This A is going to be distributed inside each term in the parentheses. So this A is going to go and be next to the B and C. So this A gets attached to the B and it gets attached to the C. So this A gets attached to everything in it and gets removed. Same thing happens with the D. The D is going to come over here and attach itself to the AB and the AC. So that'll be AB. It's going to get attached with a D. And the AC is going to get attached with a D. We could have also, this is equivalent, due to order of operations, multiplication is on the same level. A times D is equivalent to D times A. If we're having something being multiplied together, we can change the order in which they're multiplied. So A times B plus C times D, we can flip the order of these multiplications. So let's let A and D be first. So I just changed the order. So we have three terms being multiplied together. You can put them in any single order you want because they're all being multiplied together. Now we can take A and D together and put them next to B and C. So we can take here we have B plus C. We can take the A and D and put it next to the B, and A and D and put it next to the C. You could multiply them together first and then do that, or you can just put them into the equation. So coming back over here, you can either multiply 150 times 4.184 first, or you can do it last. It doesn't matter. I like just going ahead and doing how it's done in order it's given. So we have TF minus 30. So TF minus 30 in parentheses. This 150 is going to be multiplied to TF and the negative 30. So that would be 150 times TF and 150 times 30. So I distributed this 150 to the TF and the 30. Simplifying now, 150 TF minus 150 times 30. So multiplying this down, and now I'm going to come over here and do the same thing. This term, 4.184, is going to multiply to everything inside the parentheses. So everything inside the parentheses, so 4.184 times 100 times TF, and then 4.184 times 4,500. So again, I had 150 TF minus 4,500, so 150 TF minus 4,500, and this foils to each term. This would go in front of the 150 TF and the 4,500. So now I have 4.184 times 150 times TF. I can simplify that down. That would be 627.6 TF. And then I can simplify this down. And then that's the left side. And now I can do it to the right side. Negative, so I'm going to pull this negative inside here. So this negative is like a negative 1. And we can do order of operations. Multiplication can be done first. So this is the equivalent of negative 200 times TF minus 80 times 4.184. Again, I could do this any way I want to. I'm going to combine these two first. So negative 200 times 4.184, that is equal to negative 836.8. Times TF minus 80. And now I would FOIL this into each term. So negative 836.8 TF minus negative 836.8 times 80. So this times TF, this times negative 80, or minus 80 I should say, here's the minus. So that would be equal to negative 836.8 TF. A minus and a negative makes it plus. And now we're down to the last equation. We need to get everything to the all the TFs to the same side, so we move this over to the left, and we move this minus over to the right. So moving this over, we get 627.6 TF. When we move it over to the right or left, this becomes a plus instead of a negative. And moving this over, this minus becomes plus on the other side, so plus 18,828 plus 66,944. So this times TF and this times TF, these two can combine together. You just add them. It's like 2x plus 3x is just 5x. So that's 1464.4 TF. And then we can just add these two together. And now we need to solve for TF by getting rid of this term in front. So we divide by and we get 58.57 degrees Celsius. Then double check to see if the answer makes sense. If we have 150 grams of water at 30 degrees Celsius, 200 grams at 80 degrees, and we mix them together, we would expect the final temperature to be somewhere in between 30 and 80. So that checks out. I was going to be tomorrow, but I'll make it the next day. So I'm going to redo this all super quickly in another way. So let's relook at this problem. So as 150 grams of water at 30 degrees Celsius, so I know that we can imagine this as two different things. We can imagine it as a glass of water that has a mass M1 and a temperature T1, and we're putting it next to another glass that has a mass M2 TF or T2. So it's initially, so T1 is initial temperature of left water. that has a mass of M1. And let's also let the Cp of this liquid be Cp1, and the mass of this Cp, or the Cp of this liquid be 2. Another thing is y'all are leaving off the P. Don't do that. C is not specific heat. It's Celsius. Cp is specific heat. I don't know how many times I tell every single class, if I write a variable as this, that is the variable. Nothing else is that variable. F versus F, this is force, this is frequency. That's temperature, that is period. This is temperature. C is nothing, or it's the degrees Celsius. Cp is specific heat. Lowercase c is speed of light. Again, do not change any variable. It means something completely different. So, to speed run this really quickly, I like using pure algebra. So Q gained is equal to negative Q lost. My formula for Q is mass times final temperature minus initial temperature times specific heat. So this is M1 delta T Cp. So I have mass of the first one times the change in temperature times the specific heat. This should be equal to negative mass 2 times final minus initial times the specific heat over here. I am solving for TF. So using pure algebra only and no numbers, I distribute the M1N. Now distribute the specific heat N. That's the left side done. Here I'm going to do the negative and Cp both in at the same time. So this times that. So minus M2 TF Cp2. And then this term and that term times that at the same time. So minus M2 and minus T2 times Cp. That becomes a plus. So M2 T2 Cp2. Again, just algebra. Now I bring this over to this side. And this over to this side. So M1 TF Cp1 plus M2 TF Cp2. And then this over here is M1 T1 Cp1 plus M2 T2 Cp2. These two terms share a common variable, which means I can pull out that variable. So this is M1 Cp1 plus M2 Cp2, and then put the variable on the outside of it. And now I divide both sides by this term here, M1 Cp1 plus M2 Cp2, which cancels it out right here. And so my final temperature is equal to this. Plug in my given variables into this equation, and you're all done. Again, I'm not sure which way makes more sense, doing it pure algebra using numbers same time, but this is just algebra. So the mass M1 was equal to 150. The initial temperature of the first one was 30. CP is 4.184 plus M2 was 200. Its the temperature was 80. It also shares a 4.184. And then the mass M1 was 150 times 4.184. Mass 2 was 200 times CP of 4.184. And if you plug that in the calculator, you get the same result. I just decided to plug numbers in to the very end instead of plugging them in at the very beginning. Everyone good? Alright, let's look at number 19. So let's say we had 500 grams of water that heats up from negative 20 degrees Celsius to 140 degrees Celsius. What is the total heat required to do this? I recommend you list the arrows going out. So we're starting with water at a negative 20 degrees Celsius. Is water solid, liquid, or gas at negative 20? So this would be solid. And it's going to heat up. Remember, if there's a temperature change, it's still solid. So it's going to heat. So it's heating. Once it reaches 0 degrees, it's going to start melting and become a liquid and still be 0 degrees Celsius. After it's heating up, so it's going to start heating up after it's fully melted, and it's going to stay a liquid because you're heating it up. It's going to reach 100 degrees Celsius, at which it starts boiling. It's still a liquid. It hasn't fully boiled yet. And then it's going to become a gas. Each of these arrows represents one equation. The heating equations heating is going to be Q equals M delta T Cp. So for this portion right here, it is heating. So we would take the mass, 500, and we do final minus initial. So that'd be 0 minus negative 20. And we do the Cp when it's solid. So Cp solid. If you were to look at the equation, we see here liquid, solid, and gas. For solid, it's 2.06. So this was 2.06 because it's solid during this portion. 0 minus negative 20 is positive 20. So all of this multiplied together Then we have this arrow here is the melting. That's where we do mass times heat of fusion. So let me rewrite this on here. So 500 times 20 times 2.06. Then the mass is 500. The heat of fusion of water is 334. Then we have, so that covers this setup, this arrow. Then we have another heating. So we're going from 0 to 100. Delta T is 100. So the mass times delta T, we're adding 100 to go from 0 to 100. And then we use the CP for liquid, which is 4.184. So 500 times 100 times 4.184. When we're boiling, we use mass times heat of fusion. The heat of fusion of water in the problem was 2260. So add together mass times heat of vaporization, 2260. And then lastly, we have another heating. We're going from 100 to 140. So that's a change in temperature of 40 degrees. So mass times change in temperature. And we use the CP for when it's a gas. This should be gas. So 2.02. Now we just type this all in the calculator, and that's your answer. So let's do number 20. Make it simple. We have 50 grams of ice. That's at negative 10 degrees Celsius. And is added to 500 grams of water. That's at, let's do 80 degrees Celsius. So again, we're starting out on the left side. We have 50 grams ice at negative 10 degrees Celsius. That's going to heat up to the melting point. So it's going to heat up. Then it's going to melt and become water. And then it's going to go to some final temperature. We have, on this side, 500 grams of water at 80 degrees Celsius. It's going to lose heat until it reaches some final temperature. So every arrow represents an equation. And we know that heat gained is equal to negative heat lost. So the heat gained on this side, and again, let's say that ice. Ice has a mass M1 and initial temperature T1. And over here, we're going to say that this is mass 2 and this is T2. So on this one, we have mass M1 times the change in temperature from 0 to -10. So that would be from 0 minus T1 with its initial temperature times the Cp of ice. So that is this equation. For the melting, it would be mass M1 times heat of fusion. And then for the heating up, it would be mass M1 times final temperature minus 0 times, and now it is water. So this portion is water, so Cp water. On this right side, we put in a negative, and then be mass M2 times, we're going from 80 to Tf, so Tf minus whatever this temperature was, T2, times Cp of water. So 50 times a negative 10, so that'd be a positive 10. Changing temperature was 10. Cp of ice, looking at our Cp values, ice is a solid, so we use 2.06. Mass is 50. Heat of fusion is 334. Mass is 50. Tf minus 0 is just Tf. Cp of water is 4.184. And that would equal negative 500. Tf minus the change in temperature, or the initial temperature was 80. Cp of water is 4.184. Now, we can go ahead and add this together. We can add this together, and we can FOIL this out. Try to not add, you multiply them out. So 50 times 10 times 206, so these are our three terms. That is 1,045 plus 50 times 334 is 16,700. 50 times 4.184 is 209.2. And that'd be Tf, so I took these two and multiplied it together and then multiplied by Tf. These can be added together. That's one side. Now working on the right side, I'm going to multiply this and this first. And then I'm going to FOIL this out to each term. So that'd be negative 29.2 Tf, negative and negative, we're going to cancel each other out. And become a positive 167,360. Again, I need to move all terms containing Tf to one side and all other terms to the other. So I need to move this over here. And I need to move this over here. It's being subtracted on this side. So I'd add it on this side. This is positive over here. So I'd subtract it on this side. Subtract 17,745. So this is 2301.2 TF. And this is 149.16. And then divide by 2301.2. And we get 65.016 Celsius. So you're trying to group TF on the one side. So choose which side you want to have TF on. I try to make all terms positive. So I move this over here and make it positive. I think what I'm going to do is restructure the test and we'll have it on 2 days to give y'all more time to work on it. Last year and the year before, I had it all 1 day. Like 20. Except for like, so looking at how I have it currently. I have the first 9 questions, like definitions and stuff. I'll go over tomorrow when I do a test review. And then the last 10 are going to be questions like that. Except for, let's see, most of them are just simple Q equals M delta T CP. In which case you only have, this is your complete equation. I do have 2 questions that are mix and match. Oh no, I'm gonna look at it. This one go debate. Because I'm thinking about adding more problems. Technically there's 16 questions in total. I'd like to bring it up to even 20. Any questions? So if you're not comfortable with the algebra, I suggest you come in for tutoring in the morning or during lunch or something. And then you work on your algebra skills. Personally, whenever I solve these, so it might be confusing to you, is I replace everything with, except for melting point and boiling point, with variables and solve it all using variables. So plan is review tomorrow. Test is going to be Wednesday. I might expand the test and make it longer and also give y'all Thursday to finish it up. Or I should say continue the second part. I'll either break it up into 2 tests or keep it as 1 test.